I'd like to introduce Greg, K06TH. Greg is going to be presenting tonight on the solar-powered shack, or what I've affectionately called Adventures in Solar, because he's had quite the experience in it. But Greg was in the software industry professionally. He's an engineer, and I think anybody that knows Greg knows he's an engineer. That's a good thing. He is very passionate about satellites. If you turn into the Thursday night nets, we always have a report from Greg on satellites. Greg's a lot like me when I was reading the information he gave me for a bio. When he was young, he would take anything apart he could get his hands on, and he likes all things electrical, electronic, and mechanical. So I can appreciate that, Greg, because I did the same thing. That's how I learned most of what I know in electronics before I went to school. So with that, I'll be quiet and we'll turn it over to Greg. Thank you, Greg. Let's give him a welcome.
Solar-powered shack. This is a tale many years in the making. It's one of those things, you start off with going one direction, you end up somewhere else. And I'll kind of drag you through it, if I may. Think back to 2018, a campfire took out the town of Paradise. Big fire up there. Not a good situation. Sparked by power lines, the high voltage lines in a lot of wind. A year later, PG&E said, we got to do something about this, and they started instituting these Public Safety Power Shutoffs, PSPS. Where they, in advance of the wind, they turn off the power. We were hit with one for 14 hours. We were lucky. Some people were out for a week. I thought I was prepared, but I almost lost the fridge. Turns out need more need backup power. I went out and got a big battery, 92 amp hours. Criteria: it's the biggest one I could lift, and found an inverter. Ham sold me one that he had an excess based on a quick test that should last about a day. Double my outage time, should be good. And then of course if I had to charge it, I could plug it into my wife's car. A year later, give it a try. Right? We got field day coming up. We were all working from home. Run it off batteries. Class 1E, great. Until it came time to charge the battery back up. That was a little more interesting than it should have been. Find out that your jumper cables that have been sitting in the back of your car, they don't always work the way they planned on when you haven't used them for a while. One of the club members organized a group buy for some used solar panels. Said, hey, this is perfect. Get some solar panels, be nice and green, safer, right? Kind of worked, kind of didn't. Needed a better way of sucking energy out. So there was a discussion on our groups.io. Apologize for those who I dragged through that discussion, which one to get. Ended up with a Victron 100/20, 100 volts, 20 amps. And that was, that was quite a nice little purchase there. This MPPT thing that it does is the maximum power point tracking. It literally figures out dynamically on the fly how much energy to suck out of the panel to give it the most, get the most out of it they can. And then it converts that to the battery voltage and it runs the battery profile up and down for charging, which is also necessary. So, yay, that was working really well. Went from, that was a 7.46 amps, 100 watts going to battery before. After 210, the Victron was the one controller that did not have a display on it, but it's got a serial port. So, being a good engineer, with an Arduino sitting around doing nothing, cobbled together a display for it. So that worked out pretty well. I'm not going to go into any detail on that. If you want a more detailed discussion, let me know. Reality. Solar panels need to be in the sun. I have trees, which make shade. You cover one panel, one little section of the panel on the display, the panel, charge output goes to 0. They're not happy at all with any kind of shade. So means you're constantly moving the panels around on the ground. They're weigh 40 pounds apiece. That's not good. And they're just sitting in the garage doing nothing, preventing, I don't know what, they're holding the wall up maybe. So I figured, okay, new objectives. Let's put these things to work. Let's use it to offset the base load in the shack. Harvest that sun energy, offset some load that is happening in the shack anyway, and on the side be able to recharge the battery. Back of the envelope, 500 watt hours a day, 32.8 cents a kilowatt hour. Folks out of town, out of state, may think that's it's going to go up. That's the marginal rate that's tier 2 marginal rate for electricity where I am. There is a tier 3. $60 a year is what that comes out to. Yeah, it'll pay for itself in about 3 years. That's not bad. The way the system came together, the architecture, you've got 2 sources of power. You have source power from the solar panels and a 12-volt power supply. You put them in parallel. When the sun is shining, the power comes out of the solar panel. The power supply is set for a little lower voltage, so it sits there and does nothing. When the sun goes down, it picks up the load. There's also a battery in there. It's just for stability, keep the everything happy, but it's not intended to be cycled. The power supply is set to 12.8 volts, which is, if you put a lead acid battery, sit it on the floor, measure the voltage, 12.8 volts. So basically, it's going to go back down to its resting state anyway, and just be there in case there's some tug on it. All the ham equipment's on 12 volts anyway. There's a few things like the internet router and that kind of stuff. They're just sitting there sucking juice 24/7. Put them on it. Power those with an inverter. Sounds good. About 60 to 80 watts is what I ended up figuring out I could put on the thing. And that worked. In fact, I had all the pieces, right? I've already got the power supply. I've already got the charge controller. I've already got an inverter. When I bought the 2 kilowatt one for the fridge, there was another one that was kind of thrown in, didn't work. Took it apart, dusted it out, started working. Yay, use that one. I've already got some batteries. Everybody's got batteries. Longer story on that one for after the meeting. I figured, so the group buy had there was one panel left over from that, so I snagged that one. If I'm going to do this thing, I'm going to might as well put the most in as I can. Got a second panel. I got to buy some wire. They call this wireless, right? Got to buy some wire, roof supports, just a bunch of stuff, about $200. So I figured about three years I pay for this stuff, break even, and then it's all good, and I could keep charging the battery back up. On the side, I needed a new PC anyway, and that would help out with the energy budget. So there's the situation. There's one corner of the roof that gets some sun. Most of the afternoon is in the sun, and so mounting some brackets, getting lashing things under the shingles there, cement shingles, and mounted the solar panels. You can see my satellite rotisserie in the background. There's also an HF. You can't see it across the roof line there. I'll get more to that in a second. In the shack, we have the blue thing. There's the charge controller. I grabbed a rig runner. Big investment, about $75 for that. But instead of taking an octopus cable with multiple connections on it, I figured that's better approach. There's the inverter and a couple circuit breakers, and it actually worked. I mean, I kind of latched things together beforehand, actually mounting it. Thank you to Clyde for the idea of putting on a piece of plywood and then attaching that to the wall. That worked great. But issues. So modifying sine wave means noise generator. I knew it was going to be a problem. I didn't think it was going to be this big of a problem. Basically, wall-to-wall noise from 20 meters on down. Don't even think about it. Ferrites, little clamp-on things, they can buzz. They can make noise. Yes, if you have a lot of current going through them, and with a ripple on it, they buzz. And found out, you don't ground the the wires going to the panel. You end up with a ground loop. Bad idea. Design issue, knew it going in. If the inverter cuts out for some reason, I lose the internet. You got to push the button, get it back online again. Annoying, but it's there. But answer to all these things, or almost all of them, yet another purchase. A 500 VA, 375 watts is what it comes out to. Pure sine wave inverter. That's the one that's supposed to be nice and quiet. And it fixed all the noise. But then, yeah, ripple. So, being, again, not having a display on it, I had to do another project. Of course, all this equipment's mounted on the wall. So I'm under the desk with the breadboard there. I'm small, it fit. That's my linear supply in the background there. So there's the inverter on the bottom, tied in, little switch in between to get everything working there. This hum, you may have heard me on the net talking about this. If the load on the inverter is not a pure resistive load, any kind of what they call a power factor, it gets pushed upstream. And it ended up being a massive 500 millivolts, so it's half a volt ripple on a 12 volt multi-amp line. So it's pulling the battery up and down half a volt 120 times a second. That adds up to about 5.8 amps, according to a meter that I've got. Thought about, so one suggestion was, hey, get a big capacitor, like the auto business, the car audio guys. They have these, they're measured in farads. Now, to me, a farad is the size of a bathtub to a railroad car. These things are like, your mythical 805, whatever the beer can is. So, yeah, but that's a lot of energy. It's basically a dead short for a while till it gets up to that just seemed kind of dangerous. So what I ended up coming up with was a smaller capacitor, 48,000 microfarads. That's 0.048 farads. And a big iron choke. Where do you get a big iron choke? You get a filament transformer, use the secondary, leave the primary unconnected. Big iron choke. That worked. And now I had, instead of 5.8 amps of AC ripple, 500 milliamps or less, supposed to be about 375. So that really worked. Few things didn't end up being problems. So let's be fair here. Not everything went wrong. Okay? I was really concerned about RF interference into the system. We've got the antennas in the background there for my the VHF UHF 1.2. There's also, excuse me here, across the roof here, cross and down, it's really hard to see, is my HF dipole. That is, it's a multi-band dipole. 100 watts on all the bands. That's, it's right next to the panels. So what am I going to do? Looked at various ways of running the wires. Ended up with choice one there down into the right. But that ended up being a non-issue. Roof supports, I was worried about the tiles. Didn't work, didn't be a problem. The fan, the inverter's got a fan in it. The kilowatt one that I started out with was so big the fan never turned. I assume the fan works. The other one, the fan does come on. It's not very loud. It's okay. And the whole system of going from AC to DC back to AC again is rather inefficient. You lose about 20% of your power. So all the time the sun is not shining, I'm actually digging a hole energy-wise, right? And the hope is that you end up getting more energy back from the panel than you waste going out with the double conversion. I needed the new PC anyway, so I'm not counting this, accounting. The accountants in the group will say I'm doing something wrong here, but I'm not counting the money I put into the new PC. But the new PCs are really efficient power-wise. And I went from burning about 50 or 60 watts down to like 14 with the PC. So, okay, that offset all of that other power. So as I'm using this thing, I figured I'm getting a better feel for how it's behaving. And there's So I have these UPSs that have been, just the usual desktop PC UPSs. I had one running all the ham stuff off the 120, and one running the computers and the internet. Second one. They're both sitting there doing nothing. Okay. I got a pure sine wave inverter now, so I put the smaller one downstream of the inverter. So now if the inverter trips out for whatever reason, UPS kicks in. So I'm safe there. And of course, being pure sine wave, the inverter doesn't know it's not online. I mean, it thinks it's getting fed by PG&E. Okay, I'm not going to tell it. The big UPS one that ran the energy hogging PC, that one was sitting there with basically nothing on it. It was like they had a desk lamp or something. So I put that one upstream of the 12-volt power supply. So now the power can go out for, I think that ends up being about 90 minutes between the two of them. And I won't even notice it. If the sun is shining, I don't care at all. So that's great. And in fact, I had extra power being generated. I moved the PC and some monitors and other stuff across to the solar system. So now all that stuff is running off solar power during the day. And results generating over a kilowatt hour a day. That was back in February. It's 1.4 kilowatt hours a day now in full sun at 33 cents, at 0.328 cents a kilowatt hour, 33, 34, 40 cents a day all year long. That adds up. Figure I can pay back about 4 years what all this stuff cost. And of course, in the summer, it'll be even better because the days are longer and it's less shadowing from the trees. The original, don't lose sight of your objectives, right? The original objective was to recharge that stupid battery. Confirm that still works. In fact, with the rig runner, I just reel it over. I got a power pole on it, plug it in, good to go. And in the meantime, I'm using it to recharge my telescope battery. Just, why not? The best news out of all of this, and you can thank me for this, is there's never been a power shut off in my neighborhood since I started this project. In graphical form, on the left there, so PG&E customers, you can go back online and you can look in your account, and by day for electricity, actually by hour, you can look at your usage. And so on the left is back in early December, a typical, I think it was a Monday, usage midnight. So 1 o'clock in the morning, this is when the house is going to sleep, right? The thermostat's on setback. Everything is, everything's that's the minimum usage. And it's about 0.4 kilowatt hours per hour, whatever it is. That's the low point. There's breakfast. Here's the day, me in the shack. Dinner, running the microwave and stuff. There's the evening. There's my car charging. And off to the end of the day. That's before. Here's the after. We're about evenly split across the winter solstice. So in terms of temperatures and everything else, daylight, about the same. About the same down here. In fact, yeah, it's about the same energy level there. Look at what the day is. The lowest spot down here is lower than when the house is asleep. That's nice. And then, of course, dinner and the car charging. But that's and then the biggest thing is that up there. That's the main UPS driving the entire shack from the wall with 0 watts coming in. I call that success. Any questions?
The question is, was it fun?
Question is, did I have fun? Yes. This is all fun. Go ahead.
How does it compare in a winter month where we have a lot of fog and overcast versus a winter like we're having now that's quite a bit of sun? Have you ever looked at it?
So the only experience I've got in terms of weather is what we've had since about the first of the year when I started playing with the actual solar panels and that kind of stuff. When it's really cloudy outside, like rainy, cloudy kind of stuff, instead of getting a kilowatt hour out of it, I get, so the peak wattage is about 260 watts is what I can pull off the panel. That's 20 amps out of the converter. I get about 20 or maybe 40. So yeah, it goes way down. Weirdly enough, the panels will produce not so bad with just overcast. And there's less shading with the overcast because the entire sky is lit up with the overcast. And so the trees aren't casting a shadow on the panel. So it's actually better than I thought it was going to be, although it's still not spectacular. I'm getting usable power out of it. And the eeriest thing is that, the meter is sitting there telling me with the power outages, the voltage on the panels. Full moon, I get about 1.5 volts out of the panels. Haven't tried sucking any energy out of it, but yeah. So it's not as good, but on a year-round basis, I think I'll still come out ahead. Questions?
I'm just curious if you did something to attach your panels in such a way that they're kind of storm-proof.
They're what-proof?
Yeah, it looked like they were leaning on the wood. Are they attached to the wood? Are they?
Oh, they're screwed in. Go back to that. So, bolted into the fascia board there. That's all bolted together. The panels, you can't see. There's a metal tab in 2 places on each panel. You can see right down there. It's screwed in on the bottom. And this board here is lashed with wire underneath the shingles to attach it to the roof.
Are those tile shingles? You didn't penetrate through the tile, or
No. Yeah, that's I got the question. No, they're cement shingles. The shingles are attached underneath. There's a piece of wood that goes across that they kind of hook onto.
Yeah.
And they're hanging there. I lifted the shingles off without all the stuff on it. I lifted the shingles off and I put a wire up and screwed it into that board. And then the wire comes down, comes out of here, and then wraps around the piece of wood.
Okay.
So the wood can't slide down, and it's tied by the interlocking of the tiles to be held out of the roof.
Yeah, I was just initially concerned that when you have a storm front move in, if the wind is from the back side, is it going to have a tendency to lift them up? And
Understand? Yeah, that's a concern. They don't seem to move, and they weigh 40 pounds.
Okay.
So
one more. As far as the angle you used to point them at the sun, so to speak, what did you use for that?
The angle is 1/3 of the piece of wood that I had.
Very good.
It ended up being it's this thing divided by 3. It ended up being about the same as the pitch of the roof. So south is diagonally off this direction. So it's about evenly down as the roof and tilted up about the same angle to kind of point towards south.
Good enough.
No math involved other than dividing by 3.
Yeah, I was just going to say, I had solar panels installed on a cement tile roof, and you can actually buy a stainless steel bracket that slides in and is designed to go around the tiles. And it's watertight, complete fit, fully engineered. They're great little brackets.
I'd like to know where they came from because I looked and I couldn't find any.
I will find out for you.
Okay, thank you. Deal. Looks like we had a question from the internet.
Yeah, Greg, Luke wants to know how many batteries did you use?
So the battery pack, I didn't have one on here. The battery is big enough to provide stability for the system. It's actually 8 amp hour. The 3 8 amp hour bricks. They came from old UPSs. So those UPSs that I've got I talked about, every couple of years they just one of the batteries cooks, and you got to replace the battery. Well, there are 2 batteries in there. One of them tends to be dead. The other one is perfectly usable. I saved the usable one, and I keep the last 3 basically of the usable ones, and I put them in a little wooden box. And there's not a picture of it in any of the pictures, but it's just a little wooden box. I put 3 of them wired in parallel. So it's nominally 24 amp hours. 12 volts is the battery, but I've used, you could use less or more. The point is that with 2 panels, I don't have enough capacity in the solar to run it 100% offline. I can't charge the batteries up during the day and have them run all and keep going all night long. I have to have the mains anyway, and charging a battery is less efficient than just using the power. So it's all kind of balanced so that I've got enough battery capacity to keep the system stable, not invest any money in it, and have the offline is basically off the grid. The off sun rather, the nighttime is 100% off the grid. Other questions? If anybody wants more information about solar, the charger display thing, the Arduino project, that was quite a ordeal by itself in reverse engineering. And your question? I guess not. Okay. Thank you.
Thank you, sir.